All right, in 6.6, we are going to look at trigonometric equations in which the variable on the inside is either being multiplied by some value or divided by some value. So, in this first example, well, in any of these examples, we want to start out the same way as we did in the last section. We first want to get the trig function by itself. We already have that in this case. And then go to the unit circle and see where, in this case, cosine equals 1/2. Okay, so cosine is the x value. That would occur at pi over 3 and 5 pi over 3. Okay, so let's write those values down. Now, we said we're going to take whatever's on the inside and set that equal to these angles. So in this case, that's going to be 2x equals these angles. And we said also that we needed to tack on a plus 2 pi n. Now, it is important that we add the 2 pi n on at this stage, because now to get x by itself, to get the angle by itself, I need to divide everything by 2. So if I divide both sides of the equations here by 2, I'll just be left with x. Then pi over 3 divided by 2, well, that would be the same as multiplying by 1/2, so that would be pi over 6. And then 2 pi n divided by 2 would just be pi n. Okay? Similar thing happens over here. We'll get x equals 5 pi over 6 plus pi n. Now, if the question said find all solutions, this would be it, right? This would be my final answer, these two equations. But since it says find all solutions in the interval 0 to 2 pi, we need to go one step further. Okay? We need to plug in values or integers for n to see what values we would get. Now, generally, we start with n equals -1, right, and plug that into my equations. More often than not, -1 is not going to give us a value that would work, but sometimes it will, so we do want to test that. So to test, I'm just, that should be pi over 6 plus pi times -1, right? So this is pi over 6 minus pi. Well, to get common denominators, this would be pi over 6 minus 6 pi over 6. That would be -5 pi over 6. Well, that is less than 0, right? So that is not in my interval. That would not be one of my answers. We want to plug -1 in here as well. That will give me 5 pi over 6 plus pi times -1. Again, that would be 5 pi over 6 minus pi, and 5 pi over 6 minus 6 pi over 6 would be -1 pi over 6. Again, that is outside of my range 0 to 2 pi. So let's go on to the next value of n. N equals 0. Right? If I plug 0 in, I'll have x equals pi over 6 plus pi times 0. Well, that would just be pi over 6. And that is in between 0 and 2 pi. So pi over 6 will be one of my answers. Similarly over here, 5 pi over 6 plus pi times 0 would just be 5 pi over 6. So that is one of my answers as well. Let's move on to our next integer. That would be +1. So if I plug in 1 for n, that'll be pi over 6 plus pi times 1. Well, that would be pi over 6 plus pi, or pi over 6 plus 6 pi over 6, right? If we're getting common denominators, that would be 7 pi over 6, right? Pi over 6 plus 1 pi. That is actually also in between 0 and 2 pi. So we found a third answer. Let's see if we can get a fourth. And if I add pi times 1, 5 pi over 6 plus 6 pi over 6 would be 11 pi over 6. And that is actually still in between 0 and 2 pi. So we have found a fourth answer. Now, to kind of do this in your head, you just want to see if this value is less than 2 times the denominator, essentially, right? That would give us 2 pi. So 12 pi over 6 would be 2 pi. 11 pi over 6 is less than that. So that is an answer. Well, let's try n equals 2. If I plug n equals 2 in, I will get pi over 6 plus 2 pi, right? Which would be pi over 6 plus 12 pi over 6 would be 13 pi over 6. That is greater than 2 pi, so that is not going to be one of my answers on this interval. Something similar will happen over here. 5 pi over 6 plus pi times 2, right, would be 12 pi over 6 plus 5 pi over 6, 17 pi over 6. And again, that is outside of the range 0 to 2 pi. So we have 4 answers, right? And I guess I should mention the way that we know we're done finding answers is when we get a situation like this, right? Where we plug a value of n in and neither of those work. So my 4 solutions that are on the interval 0 to 2 pi would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay? Let's try another one here. Okay, in this example, we have a half angle, right? We have 2 times the sine of theta over 2 plus the square root of 3 equals 0. So first, we have to do a little bit of solving to get the trig function by itself, right? I can subtract the square root of 3 over, and divide by 2, and we'll get the sine of theta over 2 equals negative radical 3 over 2. So then I can go to the unit circle and say, well, sine is equal to negative square root of 3 over 2 right here and right here. So I have 4 pi over 3 and 5 pi over 3. So let's put those answers down. Right? And we're taking whatever's on the inside. So in this case, that's theta over 2, setting that equal and adding our plus 2 pi n. So in this case, I'm going to multiply both sides by 2. Right? When I multiply both sides by 2, I'll get theta equals 8 pi over 3 plus 4 pi n. And here, if I multiply both sides by 2, I'll get theta equals 10 pi over 3 plus 4 pi n. Okay? So let's do the same thing that we did in the last problem. Let's take values of n and plug them in. So let's start with n equals negative 1. So if I plug that in, I'll get theta equals 8 pi over 3 plus 4 pi times negative 1. So if I convert this to thirds, right, this would be 12 pi over 3. So we'll have 8 pi over 3 minus 12 pi over 3 would be negative 4 pi over 3. Well, any negative angle is not going to be in between 0 and 2 pi, so that can't be an answer. Let's come over here. 10 pi over 3 plus 4 pi times negative 1 will be 10 pi over 3 minus 12 pi over 3, negative 2 pi over 3. Again, that cannot be in between 0 and 2 pi. Let's try n equals 0. So theta is going to be 8 pi over 3 plus 4 pi times 0. Well, that would just be 8 pi over 3. Now, 8 pi over 3 is actually greater than 2 pi, right? 2 pi in terms of thirds would be 6 pi over 3. So that's not an answer. Here, something similar is going to happen. 10 pi over 3 plus 4 pi times 0. 10 pi over 3 is greater than 2 pi. So that cannot be an answer either. In this case, we don't need to continue on, right? We found a negative lower bound and an upper bound. No answers. So that means this problem has no solutions. Okay? So again, we want to find the smallest value of n for which no solutions occur, and then keep going up until we find the greatest value of n for which no solutions occur. Everything in the middle would be a solution. In this case, for example, for our second example, nothing happened in the middle, right? We just had no solutions. Let's try one more here before we do our word problem. So on this one, my sine is already by itself. I want to go to my unit circle and see where sine is 1/2. Sine is the y value, so that happens here at pi over 6 and at 5 pi over 6. So I'm going to set whatever's on the inside. So that's going to be this whole thing, 2x minus pi over 3 equal to pi over 6 plus 2 pi n. Same thing here, 2x minus pi over 3 equals 5 pi over 6 plus 2 pi n. Now I need to solve each of these equations for x. So the first thing I want to do is add pi over 3 to both sides. So here, obviously these will cancel, but here I'll get 2x equals pi over 6 plus pi over 3. Well, this would be 2 pi over 6. So 1 pi over 6 plus 2 pi over 6 would be 3 pi over 6, which would just reduce to pi over 2 plus 2 pi n. Now we don't add pi over 3 here because these would not be like terms, right? This is still something with a variable and this is still a constant. So we're just adding constants to constants. Something similar over here. Add the pi over 3 to both sides. And we'll get 2x equals, so 5 pi over 6 plus 2 pi over 6 would be 7 pi over 6 plus 2 pi n. And then divide everything by 2. So when I do that, I'll get pi over 4 plus pi n. Here, if I divide both sides by 2, I'll get 7 pi over 12 plus 2 pi n. And now we just go through the process of plugging in values of n. So start with n equals -1. So this would be pi over 4 plus pi times -1, or pi over 4 minus pi would be -3 pi over 4. Well, negative angle is not going to be in between 0 and 2 pi, so that's not going to work. Over here, 7 pi over 12. Whoops, I see a mistake. I forgot to divide that by 2. Oops. So this should just be plus pi n. There we go. So 7 pi over 12 plus pi times -1. So converting this to 12ths, 7 pi over 12 minus 12 pi over 12 would be -5 pi over 12. Again, any negative angle can't be in between 0 and 2 pi. Our next value, n equals 0. This would just be pi over 4 plus pi times 0, which would be pi over 4. So that one works. And then 7 pi over 12 plus pi times 0 would be 7 pi over 12. So we've got 2 answers so far. Let's try n equals 1. So we'll have pi over 4 plus pi times 1. So that would be pi over 4 plus 4 pi over 4. That would be 5 pi over 4. and that is in between 0 and 2 pi. And here, 7 pi over 12 plus pi times 1. 7 pi over 12 plus 12 pi over 12 would be 19 pi over 12. And that one is also in between 0 and 2 pi. Let's try n equals 2. So here, pi over 4 plus pi times 2. Well, that'll be 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. That is greater than 2 pi, because 2 pi in terms of fourths would be 8 pi over 4. Then something similar will happen here. 7 pi over 12 plus pi times 2 will be 24 plus 7 would be 31 pi over 12, which is greater than 2 pi. So we get 4 solutions for this one. Pi over 4, 7 pi over 12, 5 pi over 4, and 19 pi over 12. All right, let's do one final example with a story problem here. This one says the moon orbits the Earth every 29.5 days. And we have this function here to model the portion of the moon visible from the Earth X days after the new moon. We want to figure out when the moon is visible, or when 75% of the moon is visible from the Earth. Well, to do that, if f is the percentage, we're just going to find 0.75 of the moon is equal to this. So I want to take this equation, now setting f equal to 0.75, and solve. So the first thing we need to do is get the trig function by itself. So I'll subtract this 0.5 over. That would give me 0.25. And then divide both sides by 0.5. So 0.25 divided by 0.5 would be 0.5. So now, it might look a little bit nicer if we replace that 0.5 with a fraction, right? That is just 1/2. I've got the trig function by itself. Now we can go to the unit circle and see where sine is equal to 1/2. Well, that occurs at pi over 6 and 5 pi over 6. So we're just going to take the whole thing that's on the inside and set that equal to pi over 6 and 5 pi over 6. So I'm taking this whole thing, this pi over 14.75 times x minus 14.75 over 2, and setting that equal to pi over 6 plus 2 pi n. Same thing over here. We'll take that whole thing that's on the inside, pi over 14.75 times x minus 14.75 over 2, set that equal to 5 pi over 6 plus 2 pi n. Okay, so now in this example, let's assume that n is equal to 0, okay, because we're really not going to be concerned with going past our first cycle. So in this story problem, we can really eliminate the plus 2 pi n's. And now we just want to solve. Right? So if I multiply both sides by the reciprocal here, this 14.75 over pi, right? Right? If I do that over here, multiply by 14.75 over pi, that would cancel out, right? And we would just be left with x minus 14.75 over 2 equals, the pi's would cancel, and that would just be 14.75 over 6. I'm just going to leave it as a fraction for now, okay? Then if I add that over, that would be 14.75 over 6 plus 14.75 over 2. If I put that into the calculator, right, we can get an approximation of how many days it's been. Right? So something similar will happen over here. Right? If I multiply this over, I would just have this. The pi's would cancel, and then I would subtract the 14.75 over, and we would have 5 times 14.75 over 6 minus, plus 14.75 over 2 when I add that over. Okay, so putting those into the calculator, okay, 14.75 divided by 2 plus 14.75 divided by 6 gets me 9.83, right? So at about 9.83 days, 75% of the moon is visible. And then if I plug this one in as well, so 5 times 14.75 divided by 6 plus 14.75 divided by 2 gets me 19.666 or 19.67. So at about 19.67 days, 75% of the moon is visible as well. All right. So that is it for this video. These problems are a little longer, so we're going to do fewer of them. Okay. But the final question is going to pop up asking you what question